In this video, I'm going to go ahead and explain how to solve exponential and logarithm equations. If it becomes too long, then I'll break it down into two parts, part one exponential and part two logarithm. All right, the first part here is solving for x when the x is in the exponents. So you have two options. Option A is to rewrite this using logs, where you just write log base 3. The exponent never goes next to the base, so we're going to put 27 equals 6x plus 5. Then you can use your calculator and type that log. So I'm going to put log base of 3, 27, and then it equals 3. So with that, I'm going to just rewrite it as 3 equals 6x plus 5. This equation is just like 7th grade equation, solve for x. I'm going to pause right there and then tell you what option B was. Option B is understanding that if we can rewrite the bases to be exactly the same, we can focus on the exponents also being exactly the same. 27 could be the base of 3 to the third power. 3 to the third power is 27. So we can rewrite this equation as 3 to the power of 6x plus 5 equals 3 to the third power. And then because the bases are the same, that must mean that also the exponents should be the same. So we can just focus on the exponents and write 6x plus 5 equals 3. And if you notice, that's exactly what we had on the other option. So you have different options, but this is the option that I'm going to explain in the other examples. But let's finish this. We're going to go ahead and solve by subtracting 5. 6x equals negative 2 divided by 6, x equals negative 1/3. Let's try this example. So following the example of the same basis, we recognize that 16 could be written as 4 to the second power, and then we have the exponent of x minus 1. So because we have the same base, we can just focus on the exponents, and then recognize that this exponent to a power of another exponent, the rule in algebra was that if you have an exponent raised to another power, you multiply the exponents. So we're going to do that. We're going to have 2 times x minus 1. This is just distributing and then solving for x, which is moving the x to the other side and divided by negative 1. So x equals 2. One more example here is whenever you have a negative exponent, you do want to remember the rule of negative exponents. Means you write the reciprocal with the exponent, or you could have it also outside. So in this case, we're going to do the reciprocal of 1/2, which is 2 over 1, which is just 2. And then that just took care of getting rid of the negative exponent. Next, we recognize the base of 2 could be also written here for the 32. 2 squared is 4, 2 to the third power is 8, 2 to the fourth power is just this being doubled, so 16, and then 2 to the fifth power is 32. So we can write this down as 2 to the fifth power. And now that we have the same basis, we can focus on the exponents being the same, and we solve for x. And that's it. An example of real world of exponential functions and why are we learning how to solve equations of exponentials. It's this example. It tells you that your parents bought you a car that's $12,000. It depreciates in value every year by 8%, and the total value of the car can be represented by the function here. This is the function. And then it tells you, well, where x is the number of years since you purchased the car, when will the car be worth $9,000? So they're telling you the value that they wanted to predict. So you put here $9,000 because you're trying to calculate what x value can you have for the car to be $9,000. So we're solving for x. This right here is connected, so we want to get rid of the coefficient of 12,000. We divide it by 12,000. And then we end up with these zeros being canceled, and then 9 divided by 12 is 3/4. This right here, we do require the log in order to bring down the x. So log base of 0.92, and then the argument is not x, the argument is 3/4 equals x. This is already written, all ready for you to just type. And you're going to type log 0.92 and then 3/4. It's 3.45. We can round it to 3.45 gears. And that's an example of how the skill of solving equations of exponentials helps you. In the back of this notes, we have equations of logs. So for this one, we are going to apply the skills that we learned right now in logs and just practice. So we're going to start with asking ourselves, are there logarithms on both sides? Do you have logarithms at the same base? So notice that there are logs on both sides of the same base. Is there a maximum of one logarithm on either side of the equation? So let's see. We notice the coefficient needs to be put over here. So we're going to have log of 2x to the 4th power. And then we do 2x times 2x times 2x times 2x, and it gives you 16x to the 4th power. And then we notice that they have the same logs. So when they're the same logs, then they should be the same arguments if they are equal to each other. So we're just going to focus on the arguments. And this is similar to the previous one of exponents. We're just going to focus on the arguments being equal. And then solving for x. So this is just dividing by the coefficient. So 1 equals x to the 4th power. And then from previous units, we recall that a 4th power is like writing the 4th root. And actually, the 4th root cancels the 4th power. So we're going to do the 4th root of 1. What number times itself 4 times gives you 1? That is a positive 1 and also a negative 1. Negative 1 times negative 1 times negative 1 times negative 1 gives you positive 1. So you have two options here. However, you cannot take a negative number for a log. If you type the negative in there, log with a negative, let me show you what happens in the equation. If I put log of a negative number, it says error because we cannot do that. So what we're going to do is pretend the negative is not there and just say x equals 1. Because you cannot have a negative number in the argument of the log. All right, next equation. From these three parts, we notice the coefficient is here, so we're going to rewrite that as log base 3, and then we're going to have 2 to the 2nd power. We also notice that there's a minus happening here, which means we're going to have to apply the product, the quotient rule, which means we're going to put a division between these two arguments. And then now, back to how we did on the previous one, we recognize that they had the same log and the same base. So we're just going to focus on the arguments being equal to each other. And then we just solve for x. Sorry about that. Here, we can either do this over 1 and then solve by cross multiplying, or we could just simplify as we go. So if we cross multiply to solve two equations, we can also just rewrite this as x minus 1 divided by 4 equals x minus 4. And then to solve this, we cancel the division of 4 by multiplying times 4. And then that cancels the division, and we're left with x minus 1 equals, multiply that in, so 4x minus 16. Add 1, subtract 4x, and we're left with negative 3x equals negative 15, divide by negative 3, x equals positive 5. The bell rang and I have more students coming in, so watch part 2 to finish the 2 examples left in our notes.